everyone. Welcome to CPD Live. My name is Alice Blackwood, and it's my pleasure to be facilitating this discussion, which focuses on lighting systems. But before we begin, in the spirit of reconciliation, InDesign Media acknowledges the traditional custodians of country throughout Australia and their connections to land, sea, and community. We pay our respects to their elders past, present, and future, and extend that respect to all Aboriginal and Torres Strait Islander peoples today. And now to today's discussion, lighting and DFMA, that is design for manufacture and assembly, the benefits of integrating systems early in the fabrication process. While the benefits associated with design for manufacture and assembly are clear, it sometimes has unintended negative consequences. If not approached correctly, the fact that it involves the delivery of products that are in effect ready-made can limit design possibilities. The solution to this dilemma is to get in early, and to ensure those desired outcomes are achieved, all relevant stakeholders need to communicate early in the design process. This session examines the best ways to go about this. So by the end of this session, you should be able to, 1, outline the ways in which lighting systems are typically incorporated into the DFMA design process. 2, explain why the above is not optimal in terms of achieving preferred design outcomes. 3, outline the benefits of integrating lighting systems earlier on in the process of fabricating fittings made for engineered timber structures. 4, explain why it is crucial to understand design, installation, and procurement methodology from the outset of projects. And 5, explain why doing this is preferable from a sustainability point of view. So, some very quick housekeeping. Today's session starts with a 40-minute discussion followed by 20 minutes of Q&A. If you'd like to ask any of our speakers a question, please send a text through the Q&A field at the bottom of your screen. We'll be keeping an eye on it, and we'll either be responding by texting directly or we'll raise your question at the end of this session. To our speakers today, we're joined by Simonne Bailey, who is CEO of Light Project, Tom Curtis, who's General Manager at Light Project, and Ali Habibi, Principal Structural Engineer at Northrop. They've been prepping all week for this session and have lots of great information to share with you. Firstly, Simonne, could you tell us a bit about Light Project? What does your business do? Who are your clients? And considering today's topic, which focuses on lighting and DFMA and the benefits of integrating systems early in the fabrication process, can you talk us through some of your recent projects?
Thank you, Alice. And we're very happy to be here today and participate in this exciting discussion. And yes, we have been prepping all week. Look, on behalf of the whole Light Project team, just briefly, we are a specialist lighting supply chain company operating at the forefront of technology and lighting across Australia and New Zealand. The business was born in 2008 out of Melbourne, and we actually service and support all sectors in the construction and infrastructure industry. We do specialise in architectural lighting, delivering award-winning projects, which we'll talk through some examples today. And we have a proud history in supplying Australia's leading DFMA projects in Australia. Some of them are on this slide. You'll see Library at the Dock was one of the first, built by Lend-Lease. 25 King Street, obviously in Brisbane, a huge commercial building, fantastic outcome. But DFMA also covers integrated facades, volumetric pods, flat pack solutions, and again, we'll talk more about that later. Before I get to that, I'd like to just briefly mention a couple of examples. So Barangaroo on the next slide, please. Thank you. International House, which was the first real example of a commercial large-scale volumetric CLT building in Australia, award-winning in many ways, creating a healthy workplace, in fact, a 60% lower carbon footprint than a conventional concrete commercial building in Barangaroo. 1,700 pieces of CLT and glulam, and approximately 20,000 screws, just in case you're wondering. It is still considered a world-leading project in innovation and sustainability, and actually as an environment, because the CLT was exposed, was actually proven to reduce heart rate, blood pressure, and more cognitive ability when you're actually working in the space. A great outcome. We obviously understand a lot about DFMA from a lighting solution, but we'll actually talk about integrated systems and services across particular projects. And it's really important that they're at the beginning of the design process, and Light Project are very supportive of working with all stakeholders in the industry to do that. I'd actually like to ask Ali to introduce a little bit about Northrop, and then we'll go through the Q&A. Ali?
Thanks, Simonne, and thanks, Alice. So Northrop Consulting Engineers is it's an employee-owned based company. We are a multidisciplinary company. I'm obviously a structural engineer, but we have all disciplines. 10 offices across Australia, 500, almost 500 people. Our offices across Eastern Seaboard. In terms of a DFMA, we've done both volumetric and kit-off part. We will talk more about what are the differences, what is volumetric or kit-off parts. We've done volumetric for more schools and correctional centers, but today I will focus a bit about what I love the most, timber buildings and kit-off part for DFMA. As you can see, we've done plenty of projects across Australia. Almost all of them are the first one in that region. You can see our first job was 2015, helping Lend-Lease for International House, which was the first commercial building in Sydney. The second one in the middle, it's a honeysuckle job in Newcastle, the first timber office building in Newcastle, which is the first also regional New South Wales office building, got 6-star Green Star. The third one on the right, it is for the University of Melbourne. I love this one because I have a little daughter is going to childcare. This job, it is a commercial building, but the top 2 level is a childcare. The whole thing's going through not just the DFMA, but also after DFMA and fit out was interesting. And that's the first one in Victoria and Melbourne. Next slide, please. Then we are working on our station development in Melbourne. It's a metro. The middle one, we got this is the first actually a stadium grandstand built out of timber. We got the Australian Timber Award of the Year, which I think the whole team is proud of. I'm taking a credit at the moment here. And we have also on the right-hand side, we have the first composite, which is concrete and timber school, which we're doing in Sydney, in Balcombe Hills. Next slide, please. Yep, so the interesting 2 jobs is coming up. We are working on New Sydney Fish Market, which is massive, big timber building. So timber roof, we're doing the timber roof, and the one on the right-hand side, it seems that I'm not allowed to basically mention the name, but it's a big tech company. Both these jobs will be iconic building. It's a big tech company. You normally use their map a lot, starting with G. Cool. So that's it for me. I'll talk more about timber today and the efficiency working with supply chain, etc. through the session.
Thanks so much for that introduction, guys. So on to our questions. And Simonne, we'll start with you for this one. Firstly, could you define the term design for manufacturing assembly, or DFMA? What is it? How does it differ from traditional design?
Well, thank you, Alex. So design for manufacture and assembly, or DFMA, for some who haven't heard the term, is the process of designing parts, components, or products for the ease of manufacturing from the outset. The end goal is to actually create an efficient product that you then install or assemble on site. And because of the manufacturing components, which are replicated at scale, that actually reduces the lower cost per unit. So there's multiple efficiencies to DFMA. It is actually done by simplifying, optimizing, and refining the product design itself. DFMA is sometimes used as DFM, but traditionally we call it DFMA. It differs from traditional design, particularly in Australia, in our industry, due to the need that every detail needs to be fully designed, documented, and co-created with the manufacturer upfront to ensure that this is made and it can be manufactured. And then once it's manufactured, there are minimal changes. In fact, very few changes can then be made once it's on site, which differs from our traditional conventional concrete construction. D&C here, design and construct, or managing contractor type models, are the standard way for many years that Australia has manufactured or built their buildings. What's happened over the last 7 years is that we've been pushing, challenging, and trying to create new ways to build. And as you can see on this slide, it can come in various parts. Ali, would you like to comment?
Yeah, I think if I wanted to talk about this from a structural point of view, I would imagine most of our audiences, or many of our audiences, are architects. So in the traditional point of view, we normally receive the drawings, especially in the schematic stage, we receive the drawing from the architect. We put some early design for pre-DA, and it will go. We might not hear it for a couple of months, comes back, we start doing it. DFMA jobs is totally different. So for this one, we work much closer together early on the job. The details are important at the beginning of the job, during the basically pre-DA work, schematic design. Things like a transportation limitation. Normally you don't think about it, you don't care for the normal traditional way of concrete building. This is important and you need to put into your design. Or fire engineering. And the very, very important things for the DFMA, if you look at assembly part, is how easy to assemble this. If you don't think about this early on the design, then everything will go from being a very, very successful to a very, very poor job. And the last but not the least is supply chain. This is very important things, is how we bring the supply chain together and how that services coordination with the supply chain work. For example, we're talking about lighting now, how we can put that lighting in the structure with all other architectural requirements to make it very successful. I think, as I mentioned, that the teamwork upfront is very important. So we will sit down with our architect friends more often, and also services early on the job, unlike the traditional way of doing it.
Thanks, guys. Would you like to speak briefly to any specific benefits of DFMA? Simonne?
Sure. So there are many benefits, and the key benefits, I would say, of DFMA are multiple on projects where there is actual scale. So as you can see on this slide, it's conventional versus timber on the right-hand side. The ability to replicate either the structure, a system, and often a kit of parts, we refer to it, can actually benefit both the speed of construction on site and also the cost of the project from the outset. The other key benefit from my experience is this way of construction with timber in particular. It is very different to conventional from a ground condition perspective. So it's lightweight. Therefore, for challenging sites that you may have, there's lots of them out there, it can actually benefit to you or to review timber, even if it's not going to save money, but it actually will help the project in the first instance actually become a project. Some sites we can't build on because of the site conditions. The foundational support, less trades on site, equipment, labor, is of benefit when you're looking at a DFMA site. So you have less people on site, less movement and trucks. The delivery of timber to site is a very unique delivery system. Sometimes referred to it as Lego or kit of parts. And of course, we mentioned earlier, CLT buildings are more sustainable when exposed in the workplace environment, both from a social sustainability perspective, creating a healthier workplace, but also from a sustainable materiality and supply chain perspective. In terms of speed of construction, a typical floor plate sometimes is like for like with concrete in terms of speed and program, but the cycle time, once you reach top out of the structure, the benefits are then later on in the program. The program gains in DFMA can be approximately 15% of the program, benefiting the whole cost of the job. And obviously the client's revenue will start to come in early if they can finish the job much quicker than a conventional building.
Yeah, so I think again, I will touch on a couple of things that Simonne mentioned. I think this is a good slide here. When we're talking about faster to build, like we've done projects, most of those multi-story office building that you've seen, we have basically the builder was able to build 2 floors per week, which normally traditionally with concrete or post tension, the best you could do is 1 per week. And the other thing is there are a number of different projects that's been done and get the benefit from lightweight. Lightweight is not one part is foundation, like pour soil. The other things are these days I receive a lot of queries about existing building that you could vertically extend. Like if you go with concrete, you possibly could do 2 levels on top of it. If you go with timber, for example, and DFMA, you could go 6 levels. So the amount of benefit you get from that lightweight is very important. And that's not just because of the gravity weight, but also from the seismic. I remember I was living in an apartment that next door there was a construction. It was a nightmare every morning, come up early, listening to those big noise. With timber construction will be very less disruption to our community and also much cleaner. Most of these jobs that we've done, it's only 4 or 5 people doing the whole building, which is amazing. It's totally different because traditionally you need to have a number of different trades. The scaffolding guys comes in, concreted goes, steel fixture. There would be huge amount of people coming and going. Obviously with that, it would be very, very safer for the workplace. And in terms of weight, timber is roughly around 20% of concrete. Then you can see how much that benefit you could get from just less weight. Sometimes when you go higher, as it go the other way because wind will be the important things. But overall, it's a lot of benefit in this area we could bring with this DFMA and specifically with timber.
Thanks. I'm mindful of our time today and we've got lots to get through. Can we speak briefly to how common DFMA is and what sort of building components are relevant, is the concept relevant to?
Yeah. I think I'll put this slide up. It's mainly because this was the slide that I had my first presentation in 2015 when I had to learn timber and what is that mass timber, engineer timber is. And what I had, all these examples you can see from 2005 to 2015, you can see the number of DFMA timbers increasing around the world, but I didn't have a lot to talk about in Australia. We had 1 or 2 thanks to Lendlease that put 1 or 2 in 2009 and 2012, basically. But after that 2015, which our journey started, until now, it's only 7 years. But I could tell you, just in the last Timber Award, it was around 100 applications just for the Timber Award. That shows how common now this become. But again, in my opinion, still if you ask me, I would say a huge room to improve, it's people get slowly. Some of the suppliers are more comfortable with the DFMA, they're getting into that. Some of the builders, previously we had only 1 or 2 builders. Now we have 8 or 9 builders in Australia that they're doing that. And the supply chain is much easier because of people get to know how to get whatever we have in Australia, and if required, what we can import and export. So what do you think, Tom?
Hi, Simonne, did you have anything you wanted to add to that, or shall we segue into the next question?
Wait, sorry, I was on mute. I'll just
sorry,
answer that from my perspective. I didn't realize I was on mute.
Apologies.
Look, I agree with Ali. I think it's obviously becoming increasingly more and more popular as a building methodology and previously associated with smaller scale volumetric models. And now we've seen this shift towards a kit of parts methodology. And this is really exciting to us. I think you're now seeing the opportunity to do mass timber structures that offer the benefits from a sustainability model. And then all the other things we talked about previously with the cross-laminated timber and glulam prefabrication. I think in terms of building components, Alice, which is what you asked, it's DFMA has primarily been focused on building structure, as this makes up about 30% of the building's gross floor area, and office and services like mech and elec are fitted out with more conventional methodologies. And this is where we're seeing the opportunity to extend DFMA's capability to include integrated services and a more considered approach to design. I think the benefits of clear about expanding its scope, and then I suppose educating people around supply chain and prefabrication possibilities.
And Tom, could we start with you? Could you outline the ways in which services and lighting systems are typically incorporated into engineered timber structures?
Yeah, it's interesting, right? So typically services, particularly lighting and HVAC, they're considered in isolation from the structural design from the outset. This separation of structure and services often leads to projects requiring services to be expressed, and then potential for on-site adjustment. The service reticulation needs to be informed by the structure, but can also complement it. Although services being exposed has its own architectural aesthetic, this limitation can often lead to a disconnected design that expresses serves as a secondary layer in the building, and that can reduce the volumetric scale of a particular space. Now, there's nothing wrong with that if it's done intentionally, but I think the opportunities are severely limited when it comes to a more integrated design approach from the outset. And this is what we want to see develop over the next period of time. Ali, your thoughts on that?
Yeah, I think, again, I'll bring one of the example of recent jobs. It is still the mindset in our industry is DNC for many jobs, which is design and construct, as Simonne mentioned it before. The problem with this DNC, like we work as a consultant, even if we work very, very collaboratively together, architects, us as structural engineer and services, we design things. The problem here that after that 70% tender, the service engineer will go out, and then what will happen? The subcontractor from builder will come in. And that's where the problem will start, because they disagree with that. There is no continuation of the work. And then on top of that, then you see, then after subcontractor will go to then supplier and say, for example, we want this type of lighting, we want this type of HVAC system, blah, blah, blah. And with DFMA, it's too late to do this at that point. Even if you do it, it comes a clumsy outcome. So what we should do, we just need to do a lot of like redesign, and that's, it will affect the architectural intent. It will affect what the end client wants. And it's also hurt us badly because we're going through this and sometimes we cannot find it. Then it's become really ugly attachment to a system that should be very, very beautiful and aesthetic in point of view. So I think changing that mindset is very important. It's normally when we talk to end client and developer, I normally say, we need to change that. That when you think about manufacturing assembly, that should be in front of your mind from day one.
And Ali, oh, sorry, I got a bit of background noise there. Ali, starting with you, can you explain why this is not necessarily optimal in terms of achieving preferred design outcomes?
I think one of the, again, I tried and I promised to stick to a structural point of view, which my expertise is with the DFMA, you want everything to build in factory, yes? So you want, bring it on site, everything ready, made and assembled. One of the biggest point is penetrations. So when you have different services, whether it's electrical, mechanical, hydraulics, normally, because if you have a beams and a slab system, you need to go through some of the beams because you cannot avoid, some beams you can avoid. These penetrations, when it's done, CNC machine, for example, for timber in Europe or in Australia, this is done. So if we don't basically do it properly, it's sometimes I found like, it's like a IKEA, you buy something from IKEA, come home and you see, oh, none of the bolts are matched, the holes are not there, you need to go and buy new tools and connect it. That defeats the purpose. I would say it's exactly the same things. The whole idea of DFMA, you get the job done, and bring it on site, and to be very easy to assemble and make it much quicker. And that's that cooperation upfront, and bringing the supplier as well as installer upfront, give you ideas of what is the best outcome. Working together, it's the one that's basically, it's going to give you the best outcome. Tom, do you have anything to add to this?
Yeah, I do. So I think it's important to understand the way that the structure is the primary influencer of a building design. And I think what has come about in many years really is the access to BIM modeling and clash detection software. There's sort of no reason that over multiple discipline design approach can't be modeling off the same documentation at an early stage. And even supply chain has got to a level where they understand the tools available to them and then how to support a project by giving it relevant information. And this isn't just around the space taken up by a fixture or a luminaire from a lighting perspective. It's also about the way the cable reticulates between floors and how it interacts with multiple services in that sort of built environment. And I think this is where we've seen the opportunities arise. If everyone's on the same page with a similar project outcome or objective in mind, the software and the ability to design live with multiple stakeholders is definitely a huge opportunity to collaborate better with experts in their own industry, right, to produce a better result. I think that's where I'll leave that little statement for you, Alice.
Thanks. So moving on, what are the benefits of integrating services, including lighting systems, earlier on in the process of constructing buildings made from engineered timber structures? Tom?
Yeah, I think that's a good one. Even if you go to the next slide, I think, Alice, there's a couple examples of International House and Durham House as well, which are two sort of buildings next to one another. And I think International House was the first one done, and it was the first of its kind. And there was a lot of lessons learned across that project. Now, in that image on the right-hand side of the screen, you can see the glulam beams and that have prefabricated penetrations for services to pass through. And then also on the underside of the glulam beam, there was an existing or a manufactured rebrake created to allow the spatial volume to remain high. So basically the bottom of the glulam beam dictates the the lowest point of the building. With Darramoo House, it was the second building done, but in order to reduce cost and speed, basically they went back to a more conventional method where the services are expressed underneath the structure, sort of constricting or the volumetric scale, which has a different aesthetic. So it's a matter of balancing, I guess, through early collaboration, what the project outcome and architectural opportunities are, and how you understand material wastage, construction program to improve an end design result. From the outset, I think for all DFMA, there's an opportunity to engage with expert advice early. And the beauty, as Ali sort of alluded to earlier, is that with a DFMA response to design, you're more likely to have better visibility and less likelihood of the design changing later on, which means you can track the program better and keep stakeholders informed with next stages of the project. Ali, across to you.
Yeah, I think I would say go to the next level. Yeah, so it is good that you be at the moment our industry focused on the structure and architecture upfront. So slowly we're going to building services. But to me, if you want to expedite the assembly process, the DFMA should include everything. I was just looking online the other day, and I see Amazon, for example, at the moment there are big houses, small houses, all DFMA. So it is not just a structure; it has all the lighting, mechanical, everything system in it in a pack that you basically could assemble it. It's not a big house, but it is a small house. That to go to the next level, I think this mindset should come for whatever in this building is, not just the structure, including lighting and all other basically services.
I think as well, it's actually interesting when you talk about lighting, because it is one of the ones that takes up a little less structural real estate than other services. And also it's a conduit of electrical information, right? So the opportunity to expand on it being just a luminaire that's providing lighting and it's basically choreographing user experience or taking a more human-centric approach or a data approach to the way buildings are monitored and managed is an interesting opportunity to explore once you're engaging with supply chain on what your actual outcomes and deliveries around that building objectives are. Conversation.
So Simone, coming back around to you, could you explain why understanding installation and procurement methodology is crucial to achieving a positive project outcome?
Yes, so as mentioned earlier, and many of the responses you'll find, the benefits of time and cost are material in a DFMA project. But the benefits are only realized once the whole team actually understands not just the design, the client also understands the project and how it will be assembled. The delivery team understands how to deliver it. And the only way they can do that is if the supply chain partners are also working hand in hand with the manufacturers from the outset. So that whole methodology of one team co-creating at the beginning is just as important as then working out how to assemble it on site. So that design intent from the outset plus the assembly methodology will then create that vision for the project. Why that is, the design can't be done in isolation from a manufactured mindset, as Ali mentioned earlier, which happens a lot in conventional building methodology. The design principles and how sometimes the methodology will dictate potentially the design. For example, the maximum span, the design possibilities may actually be enhanced or could be limited to what's possible in a timber structure. Facades are the same. You know, we like to innovate in facades, integrate more products in facades. We see a lot more of that happening in our industry. By understanding DFMA, it actually can enhance the vision by all and actually create a better outcome for your clients. So integrating the design team, manufacturers, supply chain partners up front, and co-creating that design to meet the brief, that will gain program gains in the design phase as well. So when we talk about time and cost, we're saving time in design, we're saving time on site, and then we have a whole team working and actually sharing knowledge, which again is very important in our industry. The other area we're all experiencing during COVID is obviously supply chain challenges, procurement, lead times, lots of programs are slipping. Another benefit once you've designed a DFMA project, you're locking in your supply chain a lot earlier. This is going to have a huge benefit for the cost of the project, the lead time, and hopefully meeting that program, if not beating it. Ali, would you like to comment on that?
Yeah, I think for the traditional, I'll like to bring the example. Traditional way of doing things, we design, and we expect when you go to site, you receive lots of RFIs and you fix it as you go. That's why, yes, doable, but you need more people and more time and man hours during that time. For this one, if you do it right, so basically you don't want to receive any RFIs on site. So basically you want your design and assembly and construction sequencing to be inch perfect. They go on site, you go and said, yes, 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 all good, let's go. But in many cases, if you don't do it this way, you receive more questions from site that you weren't proud of that DFMA. You know, you still stay in between the DFMA and traditional way of doing things. As I said, I will come back again to that IKEA example. That's it to me. We just need to think it that way. While I was talking, I saw one person also comment, which was a good comment coming up, says, look, we possibly need a builder that's specialized in DFMA. I would say, no, we need, yes, that's true for the builder. But I think all of us in that industry, we should think differently when we design DFMA. We should, and it might be in one organization, some teams that they specialize and focus on DFMA and think from A to Z, from all of those details and bring it all together.
I'm just scanning through the questions too. Moving on, when is it appropriate to use timber and can you use it for every topology? Simone, over to you.
There are lots of benefits of using timber, but not every typology and not every building should actually be 100% timber. There's lots of factors in determining this, and from our experience, I'd like to share a few. First of all, height hierarchy and what you're trying to achieve. Sometimes timber is not efficient. For example, at lower heights, 0 to 4 stories, sometimes it does not create those cost savings as mentioned earlier. 4 to 8 stories, there's efficiency there when compared to conventional. And then taller buildings and structures, which Ali will talk to, sometimes it's better to look at hybrid structures, so timber and steel, for example. The size and type of floor plate also needs to be tested. Some floor plates are very efficient, and of course then it makes sense to filter and review your design very early to realize DFMA might be of benefit. And of course, a healthier workplace. When timber's exposed, that creates that environment. We also have tested many, you would think with fire, your BCA code, there's been a lot of advancement now evolving in Australia because more projects are looking at timber. We're certainly seeing, if you like, more people testing it early on. Cost is another issue. So in terms of timber, we're seeing more people look at it because of the cost increases in steel. So I think there's lots of benefits of using timber, but I don't think it's always going to be of benefit on every typology. Ali?
Yeah, I think it's a good question to ask me. For many people thinking about, I would say, every job should go timber because I love timber. But I'm with Simonne in this. The reason is, in my opinion, using sustainable material is important, but having a sustainable design is as important, if it's not more important than using sustainable material. What does that mean? To me, sustainable design means get the best material at the best location and get the benefit of what they could offer you. So if you're talking about timber alone, if you want something pure timber, just give you a rule of thumb, up to 10 story you could possibly make it. It will reach. Like more than 9 story, it will be hard. Every member sizes will be big, and then there is a job in Norway that is 14 story, but they had to add some concrete mass, because they want it to be more heavy for the wind. But I would say around 9 to 10 story. Above that, you need to go hybrid system. Most of the jobs that I will look at that, I will have a look and say, like, okay, is it the core should be concrete? Possibly yes, because of all the fire rating, etc. Can you use some steel element here to reduce the head height? Yes, you can do that. And also, at the moment, I think there is a tallest hybrid system a hybrid building that's been built is Ho Tower in Austria. It's around 70 story. Sorry, 70% of that is timber, but they are now planning around like a building hybrid system in Switzerland. The company that we work with them is around 100-meter tall timber building, but it is hybrid system. So to me, for many occasions, hybrid is the best, but some areas you could go anything below like 10 story, you have repetitive things, you could minimize the sizes, timber will work well as well.
Thanks, Ali. Now, I'm very mindful of time and we have lots of questions from our audience. So we'll go to our last CPD question. Starting with you, Tom, can you explain why integrated lighting systems earlier in the fabrication process is preferable from a sustainability point of view?
I think it comes down to a couple of key points. One is it's a service that's easy to integrate early on in the fabrication process. And two, designing a lighting system now goes well beyond the functional lighting alone. It acts as the conduit, allowing for a more responsive or efficient building model. The benefits of early fabrication or early understanding of supply chain is you can design to minimize material waste. There's an opportunity to reduce embodied energy and consumption through the DFMA building model. And then there's also an opportunity now to select materials, even from a lighting perspective, that offer 100% recyclability. They're known as red list approved fixtures. And then you can also look at the ways, once you know what your power consumption is, your supply model is and how you integrate back to other sustainable energy resources like solar. In addition to this, there are other elements of data reporting and efficient building management systems that can be incorporated through the lighting system design. But really, with the early integration of services into DFMA, it is still at its infancy. So it's just the start of the conversation, is creating a dialogue that gives, I suppose, the exploration and opportunity to figure out what the opportunities are. How far can we take DFMA and prefabrication and an early design model across multiple disciplines that overall benefits the speed, the cost, and then the building outcome? I think that's how I can wrap that question up for you.
And Ali, did you have any final comments before we go?
I would say, like, yes, lighting is important. What generates that electricity for lighting is important as well. So I would say, for example, from timber point of view, if you have a really good lighting system with a low energy consumption, at the same time you have a solar panel, but you need to bring it early on. How this will sit in the structure? Should we just put it on the roof? Or is there a new technology you could utilize the facade system around it? That will be nice, as well as generating some energy for that lighting system. So I think when we look at sustainability, we shouldn't look just on the sustainable material like timber. It's everything in that building. We should aim for sustainability through that building.
Couldn't agree more.
Thank you, team. This has been really illuminating and valuable. I'm going to go to a few of the questions from the audience. Katie has a question about skills and capability. Do the presenters have any thoughts on capability for large volume DFMA delivery in regional areas? Are skills widespread or localized to specific groups and regions?
Yeah, I'll start with that. It's a great question. Obviously, in the last few years, we've seen an advancement of many other builders, subcontractors, supply chain partners better understand the methodology. But certainly in terms of skills, look, if you're on a project and you're delivering it, whether it's in a metro area or regional area, the key to DFMA is in the methodology, and that has to be predetermined in the design phase, which means it comes with clear instructions in terms of install and assembly. So it can be done in any location. Ali, do you want to comment on that?
Yeah, I think the other things, many builders that you think that they are basically expert in DFMA, at least I'm talking about timber point of view, they bring one person that was experienced, for example, in Europe. The rest of people that are installing things, they are the normal carpenters that they learn. They will, because it is not that difficult. If you do it properly, as Simonne said, during the design, the assembly is not hard. If you do it one job, two jobs is done. And now I think we have good amount of companies in Australia that they could service regional area. And to be honest, if the transportation is hard for some of the regional area, DFMA is the best solution for that, you know, rather than just bringing, because you need to bring anyway concrete, a good concreter, you need to bring someone to put a scaffold up, etc. Here, at least you need to bring 4 or 5 people rather than like 20 people or 30 people.
And Katie, I'd also say that having delivered some projects on site myself, a lot of our younger project engineers, design managers, it's a lot more, if you like, the technology and the digital platform that's being designed, you'll actually find a lot more people on site actually understand it more than you think. So it's a great team-based type of methodology to bring everyone in. It doesn't just have to be the senior construction managers or project managers that need to understand it either.
Yeah, and I agree with Simonne on most of that. Where regional or non-regional, it's just a different type of building methodology, and the sooner it's understood or rolled out globally, you can already see that through Ali's slides earlier, the scale in which we're getting to, but that's just leading to a more understood workforce to deliver these type of projects regardless of location.
Thanks, guys. Now we have a question for our slide operator. If you could flip back to the assessment questions, question 1 through to 3. Thank you. And then Laura from Bureau SRH. says, do you know of any CLT in the hospital healthcare space in Australia or abroad?
I had a look on. I don't think that there is at the moment in Australia. It's if you're talking about medical center, yes. At the moment, we are doing a preliminary design of medical center. But hospital, if you're talking about big hospital with operation system, the problem for CLT will be the fire engineering. It's doable, but if you're going to do it from our point of view, if you want to make it cost effective, you possibly need to cover some part or many part of that timber because of the requirement for the hospital from fire point of view. In addition, the other thing is vibrations that we normally talk. If you are wanted to go next to the operation theater, you would like to have enough mass in that's not going to vibrate, because it's a small little vibration counts. But for many of those, I would, let's say, call it light medical center, definitely is doable.
I'd also add to that because if you think of a hospital, it's very repetitive. So if you looked at your your rooms, they can certainly be designed in a volumetric design methodology, but exposing the timber, I would think, would be very challenging in that environment. But in terms of a system and a kit of parts, I think a hospital would lend itself very well to DFMA.
And we've done a couple of volumetric actually for hospital, but one more still volumetric DFMA.
So Anthony asks, if services are fully integrated into engineered structures, does that potentially create problems with the adaptability of the building in the future? For example, change of use or program, or is it more of a loose fit integration?
I'll start with that. It's actually, it benefits the future proofing of the methodology of the building itself. So a lot of the time when you're designing these types of buildings, you actually are looking at the lifespan of the building and you're measuring that over time. So for an asset class, it's a very smart way actually to look at it, fully integrating your services, because when you've designed it that way, you know where everything is, first of all. So when there is a problem, a defect, or after end of warranty period, you actually can go back and track where everything is because you've captured it in the design process at the beginning.
I think it's a very good question from a timber point of view, because we got this question a couple of years ago for one of our jobs. And normally what we do, basically we're talking about future proofing in terms of services will be some penetration. For a slabs is not that hard. You could still manage it in future if you want. For beams, we normally future proof. We put some additional penetration, for example, if there would be some cabling going through it, or if you need to also design some area as a softer spot, we normally do for the concrete building anyway. Someone, the new tenancy wants to come put inter-tenancy stairs, etc. If you think about it like any other jobs, I don't think that's a big problem, and it might be possibly easier to cut like one part of a slab if you design it in timber compared to a post-tension PTA slab. It would be very, very, very difficult to cut some part of it, and you normally need to do a lot of scanning, etc. You might not achieve what you want.
I think to add to that as well, there's obviously in a lot of these CLT or timber structure buildings, we're talking the structure's expressed. So that means that there's also visibility on the services reticulation or some of these other elements. So rather than, as you said, it's well documented, but even if it's not documented correctly, there's an ease of access to basically understand where the services are running in scope just by the nature of typically an expressed structure environment in CLT or mass timber engineered structures.
There's a question in here around timber supply, and can world's timber supplies, let alone Australian timber supplies, really cope with the increase in these buildings using timber? What are your thoughts?
I think I would give two different answers. One for Australia, one for Europe, basically, and North America. For Australia, I think we need to do a lot of work for the next 20-25 years, because I would say at the moment we don't have enough if the demand increase. From CLT point of view, yes, we've got good. From glulam point of view, it's not just also that They basically, the trees that we have, first of all, in Australia, we have radiata pine. Unfortunately, we have a lot of fires. Sometimes it's wiped out some part of our forest, which is very sad. And also on the other part, from European point of view, they use spruce. They are slightly better timber material, and they thought about, or they did it 60 years ago. I think I would say when I was talking to European supplier, they said, for example, for Austria, the amount of spruce that they have versus the demand they have internally is like only 4% used internally. So 96% of that timber is available. But when you're talking about the demand, in my opinion, supply and demand work hands in hand. The more demand in more countries would think about it and put more. At the moment, Australian government is putting good fund and good research behind it, and we are starting to do a lot of like a sustainable forestry. Hopefully in 20 years, 15, 20 years, we will be, we basically manage our own, supply chain rather than just relying on European.
I think that's a really valid point, actually. The renewable resource or the opportunity to grow timber is by far outweighs the damage being done through accessing steel and things like that. So I think, as Ali said, supply and demand, although you put it quite well, Ali, there's probably not enough timber at the moment. If we saw a dramatic uptake in timber, engineered timber mass structure, I think that just by promoting it and talking a bit more about it, it's not an issue because we can create it for future generations, I suppose.
There's a couple of questions here around protection and precaution. What are the requirements in terms of termite protection? What kind of treatment is required? And then secondary to that, any extra precaution required in cyclonic regions?
That question is asking me about the first one is the termite protection. I think the termite protection, the easiest way, you normally elevate timber. So you don't want the timber to be in touch with soil, obviously. That's why if you look at any timber buildings around Australia, whether the timber components start from level one is transfer slabs and the timber start, or if it is starting from ground floor, you normally have a little bit of like a, let's say, pedestal or hub, and you put that one, whether it's in steel and concrete. But there are ways to treat softwood. That's a solution for that. What was, Alice, the second question? Sorry. Cyclonic region. Okay, so that's a good question. From wind point of view, if we're talking about, in my opinion, it is the same thing. It's just the difference between cyclonic region and our region is the amount of force and pressure coming from wind, and you will design for it. Whether it's steel or timber or concrete, you still need to design for it. Obviously, it will be more challenging in cyclonic region. Depends on what type of a structure you have. If you're going to build one of those stadiums we build in Sydney, it would be much more challenging, which I know there is a plan for it at the moment. But it means that we need to use more hybrid system to make it happen.
Thank you. And there's just so much more that we could cover off in this topic, isn't there? I know we even had extra questions for ourselves that we didn't really get to. However, I have to call time on this session now because it's going to shut us out at 1 p.m. sharp. Simonne, Ali, and Tom, thank you so much for lending your time and your expertise on this. I've learned a lot personally and find it really interesting. Thank you to the audience for your attention and also your excellent questions as well. I can see lots of little messages popping up in the chat box, which we'll catch up on once we get kicked out of this space. I think that's a wrap. Thank you for joining CPD Live. I hope you've all learned lots. This will be available on demand after the session has concluded. We look forward to seeing you in today's following sessions.